Hello everyone. Now we are going to look at leading coefficient tests. This is part of section 3.2. These are polynomials and rational functions of higher orders. Now, whenever we have a graph of a polynomial which is greater than 3 or equal to 3, then we would like to know, are there other ways by which we can actually find out how does the graph look like? One of the biggest things we can use is looking at how the graph rises or falls by looking at the degree of the polynomial. Now, this degree can be either odd or even, and also by looking at its leading coefficient. So this is called the leading coefficient test. So in a nutshell, we can say a leading coefficient test tells us how the graph, depending upon whether it is even or odd, is rising or following. So this was really make our lives very simple. Now, let's look at this test. How do we look at it? So suppose this is a graph of a polynomial. Remember, our polynomial is fx equals a sub n xn plus dot 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 a1x plus a naught. Now remember, if this is a polynomial of degree n, that means the coefficient of x to the power n, which is given by a sub n, should be non-zero. Now this graph will rise or fall. It depends on two scenarios. Here, when my n is the degree. Remember, n is the degree of the polynomial. This n is odd. Keep in mind, I'm looking at this scenario, and this n, which I'm talking about, is representing the degree of the polynomial. Okay? So if my degree of the polynomial, which is given by this little n, okay, let me write it down again, n. It's kind of not, okay, so let's write with a different color here. N is the degree of the polynomial. Now, if my n is odd, what happens? Now, when my n is odd and the leading coefficient is positive, that means a sub n is positive. What happens? Then the graph will fall to the left and rise to the right. Very simple example we just did. Remember fx equals x cubed? In our previous session, we looked at graphs of cubic functions. Now, first of all, this cubic function is an odd degree. So according to the leading coefficient test, if the coefficient, what is the coefficient over here, guys? The coefficient over here, that means a cube over here. The coefficient, let me just write it down. The coefficient is 1. And it is greater than 0. So what is happening? The coefficient is 1, the degree is odd, so according to the leading coefficient test, the graph will fall to the left, and that's exactly how the graph looks like. And it will rise to the right. So keep in mind once again, if your degree of a polynomial is odd, and the coefficient of the highest power in that polynomial is positive, then according to the leading coefficient test, the graph will rise to the right and fall to the left. Okay, now let's look at another scenario. And that scenario is when my n is odd, but the leading coefficient is negative. Then what happens according to the leading coefficient? It will flip here. It will rise to the left and fall to the right. And we just did an example in the previous video of fx equals minus x cubed. What does that tell us? When you look at minus x cubed, if you remember, this is how the graph looks like. Okay. Now, clearly, the coefficient is negative, which is minus 1 here. Okay. And the power of this polynomial is odd. So according to the leading coefficient test, the graph will rise to the left and fall to the right. Okay? Now, let's look at the other scenario when n That is the degree of the polynomial. If the degree of the polynomial is even, okay, then what happens? Now, once again, two scenarios will take place. When the leading coefficient is positive, then in that scenario, the graph according to the test is going to rise to the left and the right. Classic example, we have been doing it for so long. Fx equals x squared, guys. Clearly, the degrees polynomial is even. The coefficient here is positive, which is coefficient is strictly greater than 0, and we know the graph. How does the graph looks like, guys? It rises to the left as well it rises to the right. That's how the graph looks like. Pretty simple, isn't it? Okay, now let's look at the scenario where the coefficient of this even degree polynomial is negative. And again, we have done this examples, guys. So let's write it, say g of x minus x squared, which is basically flipping your parabola, and it is an upside down parabola, if you remember that. That's how the graph looks like. Now what happens? According to the leading coefficient test, if your graph is even, that means the degree is even, and the coefficient of the highest power here in this polynomial is negative, the graph of the function will fall to the left and the right. That's what we are talking about. Okay, what are we going to do? We are going to use this leading coefficient to describe the right hand and the left hand behavior of the graphs of the function. I've already done it, but just for a practice sake, let's repeat these things again. So gx equals x squared. Now what happens? We all know what the graph looks like. Here. Okay, now let's look at the fact. It's a repetition, guys, of what I've just done. In here, what is happening? My graph is an even, okay? The coefficient is positive. So according to the leading coefficient test, what does it mean? The graph rises to the left and right. That's what we just said here, right? The graph rises to the left and right. Okay, now let's look at a negative. What's going on? Hx is minus x squared, okay? Again, an even degree polynomial with a negative coefficient, and we already know the graph looks like what? It's an upside down parabola. So according to the, leading coefficient test, what does it mean? The graph falls right and left, to the right and left. That's this, guys. Okay, let's look at some. So let's say this is hx is x cubed. This is an odd function with a positive coefficient. And we all know, we have done a lot of practice now by now, the graph looks like this. So according to the leading coefficient test, what does it mean? The graph rises to right. It's rising to the right and fall to left. That's here. Okay, when you have hx equals minus x cubed, we just talked a few minutes earlier. It's just a repetition, guys, but it will help us to remember it also. So this is how the graph looks like, right? An odd function with a negative coefficient in the front. So what does that mean? Graph is going to do what? Graph rises to left and falls to right. Now let's take another example, which is not these simple ones, a little different one. Now here, we are using the leading coefficient test to describe the right hand and the left hand behavior of the graph of this function minus x cubed plus 4x. Okay, so let's look at this one. Now, first of all, this graph is what? This is how the graph looks like. Okay. Now, let's look at this one. According to the leading coefficient test, what do we know? First of all, what kind of a degree of this graph is? 3. The polynomial for this one is a degree 3. So let's write it down. The degree is 3. The degree of the polynomial function here is 3. So if the degree of the polynomial is 3, guys, that means this degree is, we have an odd degree. Now, odd degree, remember, it tells us what? That on one side, right or left, it will rise, and the other side, right or left, it is falling. Okay, so if it's an odd degree, this is what we're going to keep in mind. Then we look at the coefficient of the highest degree. What's the coefficient? This is the coefficient. So the coefficient is -1, definitely less than 0. What does that mean? According to the leading coefficient test, this graph will rise to left. You see this was one? It is rising to the left, guys. And it will fall to the right. And that's exactly what we see over here. Okay? So we have talked about leading coefficient test. And in the next session, guys, we are going to look at zeros of polynomial functions and more concepts. Thank you.